Hello, everybody. I want to welcome everyone to this Tech Talk. Today, we're going to be hearing from Albert from Clink. Feel free to ask questions throughout. And just a reminder that today we're also streaming on Twitch, and you'll also be able to find a recording of this webinar after it's over. Thank you.
Hi, everyone. So I am Albert, and let me go ahead and share my screen so you can see what's going on here. So give me just a second. All right. So let me go ahead and let's just get things kicked off here. And let me just open up a few things. All right, let's get started then. So today's talk is about using AI to craft conversational experiences. And I'll explain in a little bit later what that's all about. But first, just getting right into things. Who am I, right? So just a few facts about me. I am based out of Michigan. So most of the year it's pretty cold here, but right now it's pretty warm. I'm enjoying it. Also, I work at a company called Clink, and I'll say more about Clink later, but we're really focused on conversational AI and using AI to build conversational experiences. More importantly, though, outside of work, I spend quite a bit of time, working with my friends and trying to develop the Metro Detroit STEM talent. So I work with high schoolers, I work with middle schoolers, I work with, K through 5 students. And that's something that I'm really passionate about. And another thing that I wanted to just mention is because of that, I am using some of the materials that I do present to second graders today. So apologize ahead of time for some of the cheesy examples that I'll be throwing at you. But what we'll be talking about today. So just to start things off, we'll talk about what is AI. Because it's a term that's thrown around a lot, just in the media in general. But a lot of times with all the noise around, it's hard to really dissect what it really is. And next is, what does AI being applied to conversations look like? And last but not least, for those of you who are interested to learn more about AI, where should you go? And what are the kind of the first steps to learning more about AI? And before getting to the agenda, just a few logistical items. Feel free to post questions in the chat at any time, and then at designated blocks throughout the talk, I'll look at chat and kind of review the questions that's been posted there. So on that note, are there any questions before we get right into it? Going once. Going twice. All right, but at any time, feel free to post your questions. Wait, someone raised their hand. Let's see here. Yes, go ahead. Oops. Okay, looks like you're unmuted now, so try now.
Sorry, can you hear me?
Yes.
Hi, sorry. So I was like probably 2 minutes late to the Zoom meeting. So I don't know if you mentioned what project you'll be going through. So if you could maybe quickly explain that.
Yeah, so I'll talk through conversational AI, which is how do you apply AI to conversations. And we'll start with just talking about AI at a high level.
Okay, perfect. Thank you.
Mm-hmm. Any other questions? Going once, going twice. All right, let's just get into it then. And feel free at any time, when you have questions, just post in the chat, and then we will have more designated blocks for questions like this. So let's get right into it. What is AI? And at least for me, I like to keep the definition relatively simple and broad. So kind of AI, what it means to me is it really means using technology to imitate human intelligence. Now, one thing about this definition that people don't like is it really doesn't tell you a whole lot, right? Like, what is human intelligence? And what does it mean to be intelligent? So let's just take a closer look at human intelligence, and let's think about what does it mean to you. So go ahead and in the chat, just write down some of your thoughts. And I'll give you a few seconds to do it. Write down some of your thoughts of what does human intelligence mean to you? Yep, asking questions, that's definitely something that's intelligent that humans do, and trying to generate questions, that's definitely a good, could be meaningful decisions or decision making. That's another great idea, right? Detecting and connecting ideas, problem solving, thinking abstractly. I really like the term abstraction just because it is, a very common computer science term. Also, being able to intelligently make decisions based on the surrounding environment. So all of these are great thoughts. And being able to detect syntax and grammar in respective languages. Yes, that is actually really cool. And since we're talking about conversations, that's something I'll get into a little bit later. But yeah, thanks for all your contributions here. But let's just take one, look at one, closer look at one example of intelligence. So learning, right? Learning is something that's, that I think is really intelligent. I work with kids all the time, and it still amazes me how much that they're able to pick up as they're learning. So to really, take a closer look at learning, we'll do a quick activity here. So on the next slide, you'll see two groups of pictures, Group A and Group B. And now I'll give you about 10 seconds to study these pictures. So on the next slide, you'll study these pictures, and after the 10 seconds, I'll give you further instructions. And this activity is really about experiencing learning. So go ahead and take 10 seconds here just to study up these images. All right, that's 10 seconds. So on the next few slides then, based on what you've seen, try to classify the image you see as A or B. And to do that, just go ahead and put your responses in chat. So let's just get started here. So is this A or is this B? Go ahead and put in chat. So I have A. We got one B here. Another B. Let's take a look here. So the answer is A. But let's continue looking. What about this image? Is it A or B? B. Lots of B's here. Looks like there's a little bit more consensus here. So this one is B. Let's take a look at this one. Is it A or B? A, B. Let's take a look. It is A. Next. Is this A or B? B. We have an A. We have some more B's. Let's see here. This one is a B. How about this one? B. Well, let's take a look. This one is B. And then, how about this one? A. And it's A. So, we did a few rounds of this, and it seems like, although some of you might not have gotten all of them right, in general, with the majorities, you're able to, in general, learn to complete this quote-unquote classification. So how are you actually able to do this? So, for example, somebody putting some questions here. So were these pictures in the data set? I like that you used the term data set, so we'll talk about that in a bit. But no, these images that you just saw were not in the data set. And then why is the third image B? Oh, we'll talk about that in a little bit. But just looking at this, how did you learn to complete this? What was the way you kind of determined that? So here I see positive versus negative feelings. That's one idea. What are your ideas? How did you identify that something was happy or sad? Pairs versus single, smiles in A, no smiles in B. That's another idea. But yeah, let's just, break this down a little bit, right? So, we were given kind of these examples in the beginning, right? A or B, and you took 10 seconds to kind of study them. And while you were studying these images, in your head, you were kind of forming these patterns around what you saw in these examples, right? So somebody mentioned that A looks like, happy images, and B looks like not so happy images. And then after you kind of identify these patterns, then you apply these patterns to classify these new images that weren't in the data set. And to me, that's something really intelligent, right? Because you're able to take something that, you take your previous experience and apply it to something new. So that's, to me, something that's pretty intelligent, pretty cool that you all did. And I know some of you might not have gotten all of them right. You might have identified different patterns, but that's also really useful. That's another really useful insight as well, in the sense that, the examples you see around you day to day, you might learn different things from them. And that's something that's really interesting about us, in that, as humans, we might have very similar experiences, yet reach different conclusions. But let's just get back to this, right? So this is one example of human intelligence. And then with AI, what we can do is we can imitate the way you learn, like you just did, using something called machine learning. So let's just take a look at how machine learning works, right? So whereas you first kind of identified patterns in these examples, a machine learning model uses training data to find patterns. So someone earlier mentioned that, were the images in the data set? What they're referring to is the training data, right? So in other words, the way you provide examples to a machine learning model is through training data. And then next, what you then do is, you've applied those patterns to new images you see, while machine learning models take the patterns that they learned from the training data and apply on test data. And test data is just data that a machine learning model hasn't seen before. So just to kind of transfer a little bit from humans to the AI world, let's just, play with Teachable Machine by Google. It's a, kind of a simulation of AI that's pretty cool. And I'll just really quickly train a model to play rock, paper, scissors. So here we are in Teachable Machine. And right now we don't have any examples, right? We don't have any training data. So the first thing I need to do is actually provide some training data. So for green here, I'll just, do rock here. So I'll just put my hand here like a rock. And I'll just keep training it. These are rocks. So I provided, let's just say 99 examples of rock. Next, I need scissors. So let me just do scissors for purple. So now I have, about 100 examples of, purple. And last but not least, I need paper. So I'll do paper, and I'll just train up some examples of paper. So kind of like before, whereas you looked at those images that I provided with you all, now we're kind of training a machine learning model to recognize these examples. So if I do rock here, you see that this is, recognizing that this is a rock. Another thing with scissors, now it's, recognizing that scissors, and then with paper, it's recognizing that it's paper, just based on the patterns learned through the examples I provided. And just to make things a little bit more fun, I can, kind of make this an actual rock, paper, scissors machine. So, instead of green here, for rock, we want to have paper. So let's just, kind of make this, a little bit more fun. For purple, for scissors, we need a rock. I guess we can put the rock in here. And then for red, we need scissors. So now, we have an actual rock, paper, scissors machine that we trained up using examples. And why is this important? Well, if you imagine, if you had to think about all the different rules to identify a rock or, scissors or paper, it'll take a really long time, right? It's like, what's the, is my face in the image, or, trying to identify all those different roles is pretty difficult. But it becomes much easier when you're able to just show your machine learning model what it is that you're going for and the predictions that you want. So this is another way, a tool that you can use while you're programming to make it a lot easier to do these types of predictions. So that is Teachable Machine. So I encourage you all, when you have a chance maybe after the talk today, to go ahead and go in and play with it some more. But going back to our slides there, why do we start with machine learning? Well, at least nowadays, most mentions of AI is directly referring to machine learning. That being said, AI is not exclusively machine learning. There are other things involved in AI as well. Just that most of the time nowadays, when you hear about AI, folks are actually directly referring to machine learning, and that's just something to be aware of. So with that, that sums up what is AI. Are there any questions about what is AI? Or is there any topics you're curious about in terms of AI? So one question here, is this a general overview of NLP, looking to learn more about transformers? Yeah, I'm happy to kind of speak to that. So kind of today is more of a introduction to AI. So when we're talking about the AI level, kind of, we have this black box that we call machine learning right now. Today we won't talk about what goes inside of that black box. We'll more so talk about what that black box does. But I'll point you in kind of some other places later today where you can kind of learn more about these topics. Good question. Any other questions on AI? Going once, going twice. Alrighty then. So next we'll talk about AI plus conversations. So what does it look like when we combine AI or use AI with conversations? Well, the short answer is conversational AI, right? Using it to enable conversational experiences. But before I get into it, why is it conversations important, and why is this relevant? Well, kind of when I think about conversations, as kind of an educator, one thing I really like is small class sizes because I'm able to interact individually with many of my students. And the reason why I really enjoy that is because in a conversational experience, there is that exchange of information, right? It's not merely just me throwing information at you. I'm able to, you're able to ask questions. I'm able to take feedback and then make adjustments. And, to me, that's a really enjoyable and important experience that we have on a day-to-day basis. And we think a lot of the technology we interact with, it really doesn't have that two-way interaction where, you're getting a whole lot of information from what you're interacting with. So the idea is, how do we use AI to enable these important interactions that we have on a day-to-day basis? And here is, where I kind of put in a little bit about Clink. I won't say too much about Clink, given that this is more of a broader talk. But, Clink, given that we do conversational AI, we have, a lot of good examples of, kind of experiences that we can build using AI. So with that, I'll just, kind of show you a quick demo. So this demo is of one of Clink's products called Finie, the financial genie. It's just a kind of a chatbot, even though that doesn't fully describe what it is. But basically, it's an intelligent assistant that can help folks with their financial planning and their financial needs. So let me just, let me first stop sharing and reshare so I can share the sound through my speakers. So give me a sec, and then we'll take a look at that demo. So let me reshare, share computer sound, desktop 2. All right, so let's just take a look at this demo.
Just go ahead, get in the car. I'll be right there. Come on, Mom, we're really late for school.
Hey,
I could use some caffeine on my way to work. Do I get any rewards at coffee shops?
Unfortunately, you do not have rewards offerings for coffee shops. However, I can offer you a new credit card with these rewards. Would you like to find out more about it?
Yeah, sure, let me see.
Based on your need for rewards at coffee shops, this platinum dining card would be best. Would you like to get it?
Interesting. My husband has been flying a lot with his new job. I'd love to get some rewards for all the miles he's getting so that we can take that nice vacation. Are there any cards for that?
Based on your need for rewards for travel and hospitality, this gold member card would be best. Would you like to get it?
Perfect. Let's do that one.
Your new gold member credit card has been confirmed.
So here we saw a short interaction, but oops, let me close out YouTube real
How do I
quick.
even sort these?
Okay, closed out YouTube. All right, but yeah, that was a short interaction, but there are a few different important things going on, right, that I think is worth paying attention to. So for example, you heard human-like language, right, in the sense that when we communicate with each other, we usually don't follow scripts, right? If you can imagine like a lot of the robocalls we interact with, there's a very set yes, no kind of dialogue going on. But in reality, when we're interacting with each other, the way we talk to each other is a lot more open-ended. There may be a lot more ums and buts and other filler words, or there may be just someone, thinking out loud and, having multiple thoughts coming through at once. And one thing we can do with AI is help, understand that messy language. So just, going into more about conversational AI, we use AI to imitate how humans interact during conversations. So for example, a machine learning model would predict the intent of your queries. So what is based on your intent, how should we respond? And how does intent classification work? So whereas before we were playing around with images as your data, right? Now we're doing something a little bit different. Instead of using images, we're using text, right? And for each of these texts, instead of saying whether they're rock, paper, scissors, we're saying we're labeling the text with their actual intent. So for example, here, show me your moves. That is, indicating dance move start. So is do the dance and so on. And color start. What's your favorite color? That's one way of indicating that someone would like to find out what your favorite color is. And what's your name? Who are you? Those are all ways of indicating the intent of asking for someone's name. So similar to what we did with images, you can use machine learning to classify text as well into their intents. And the way the model would work is that, you train the model using, this training data. Model will learn the patterns within the text, right? So it'll learn the syntax, it'll learn the vocabulary, it'll learn the words that show up. And then based on, these patterns, it'll classify the query into whichever intent it is. So my next demo here is Ollie Owl, the teaching assistant. And this one actually isn't built using Clink. This is built using Cognimates, which is a AI education platform built by the folks there at MIT Media Lab, and something I use for my, my courses for kids. So, and I think this is also a good way to just take a look at code in a block way, so it's easier to explain versus just looking at pure text code. So let's just take a look to see how Ollie Owl, Ollie Owl, the teaching assistant, works. So here is Ollie Owl. Let me just zoom out a little bit. And this is just, something I use to keep the kids entertained. So for example here, let's see. Do some dance moves.
I like maize and blue because I went to Michigan. Go blue.
Ollie Owl there decided to misclassify because I didn't train it with enough data. But let's try something else like, what is your name?
I am Ollie Owl, the virtual teaching assistant.
So that's another example of how Ollie Owl works. So going into the code though, let's take a kind of deep dive of how Ollie Owl is working under the hood. So first I have kind of a non-machine learning example, right? So here, all it does is when I press the up arrow key, it'll listen while I'm holding down the up arrow, and then it'll listen for my latest speech. So if my latest speech will show me some dance moves, it'll do the dance moves. If it's, what is your name, it'll give me the name, and if it's a favorite color, it'll do something else. So let's just try out how the up arrow works. So what is your name?
I didn't get that. Try asking for my name or favorite color. I'm also happy to show you some of my moves.
So that didn't work. Let's try something else. Show me some dance moves.
I didn't get that. Try asking for my name or favorite color. I'm also happy to show you some of my moves.
So you see there that the issue with kind of this approach, that's a non-machine learning approach, is that the things I say have to be very exact, right? So I have to say exactly, show me some dance moves, or what is your name, or what is your favorite color, in order for Ollie Owl to work. And this doesn't really reflect, kind of a human conversational experience. In reality, we might not say what is your name. We might just ask, who are you? Or instead of what is your favorite color, we might just ask, is your favorite color green? So there's a lot more variety in how we actually interact with each other. So how can we build that flexibility into a conversation? Well, if we use machine learning, let's just shift to the right tier. So now, we have a few more blocks here now. Instead of using the up arrow key, we're pressing the space bar. But before, going into, this group of if statements, what we're actually doing is we're using machine learning to predict the intent of whatever I say, and then based off the intent, then doing something. So now if I say dance moves, so this was one example. Let's try something else. Like, let's just say, is your favorite color gray?
I like maize and blue because I went to Michigan. Go blue.
So you see that Ollie Owl now is a lot more robust and is a lot better able to just understand what I'm saying. And we have a question here. Would there be a difference between saying dance moves or move? Is that sensitive to the text used? Great question. So let's actually look at the data within the machine learning model used to train Ollie Owl here. So this is kind of under the hood. So it has, kind of the training data here. So we look at dance move start, name start, and color start. These are all the intents. And here are the different ways, the different training examples we provided to Ollie Owl. So what you see here that, through this, we're able to provide a lot more variety. But one other thing that I want to highlight here is that Ollie Owl is not purely just memorizing the training examples I provide here. So for example, here, one thing I could ask is, are you a fan of gray? And even though there's no exact match for are you a fan of gray and color start, it's able to kind of learn the patterns from the text here to make a prediction and say that this is color start. So for example, I've trained Ollie Owl here, so I can just say, just to test it out, are you a fan of gray? Predict. So you see that are you a fan of gray is, categorizing as color start, even though it's not an exact, example that was provided to Ollie Owl. So this goes back to this whole idea of, whereas you as an intelligent human, you learn from your past experiences and you apply what you've learned to new experiences that you encounter. Machine learning is kind of doing something similar in that we're providing a lot of training examples, which is kind of synonymous to, or in parallel to, or analogous to, human experiences. And then the machine learning model then is applying what it has learned to kind of the new data it encounters. So, is there a difference between saying dance moves or move? Well, let's just take a look to see, if move would work. So here, move. So you see here that, again, going back to this fact that with machine learning, we're providing flexibility to the conversation and how folks interact with each other. But going back to, kind of our slides here, intent classification is just one example of how AI is using conversations. But you can also use AI to do other things involved in conversations as well. So for example, there's slot value pairing, which you see on the left. There's this whole idea of, in a lot of your interactions, you need to actually extract information from the user. So for example, here, if for someone who's trying to do an account transfer, we need to know the amount that they want to transfer, where the money's coming from, and where the money's going to. And one thing you can do is you can train a machine learning model to recognize what are the things it needs to extract into those slots, right? Or pair with the amount, origin, and destination slots. And that's one other way that AI and machine learning is used in conversations. Another example is slot mapping. So for example, if you imagine with checking, there might be multiple ways for someone to say that they want to transfer money from their checking account. Or maybe they even had a typo and they misspelled checking. And similar to slot value pairing, we can use machine learning model and train the model to recognize, hey, should this be mapped to the checking, entity or to savings? So we got a question here. When you trained the model, did you have to stem lemmatize it first so that there is that flexibility, or does Ollie just recognize it automatically because of its built-in pattern recognition? So yeah, so I can talk a little bit about that, given that it's a little bit more advanced topic. So just for the other, those of you on the call who might not know as much about NLP, what happens, one thing that's important to also talk about is with this text data that's being used to train the machine learning model, we can do some more processing on this text to make it more recognizable to the machine learning model. So for example, there's this whole idea of stemming or lemmatizing words, which is just, taking a word and turning it into the base form of the word. So there's a few things, right? So in Clink itself, my employer and, our product, we do use a lot more text pre-processing, right? So, for kind of large scale models, that text pre-processing would enable, you to build more robust experiences. But Ollie Owl itself is, once again, this is an educational tool, so it's not really advanced. And it's using a open API, called uClassify, to just do the text classification. And don't memorize my words here, but I believe uClassify is only learning based on the word itself. So it's not doing anything particularly advanced for the text pre-processing here. And also another thing to keep in mind here is with Ollie Owl, we only have about 10 examples in each intent. And in reality, with production grade applications, you might have 300, 400, even thousands of data points to train the actual model, and there's a lot more intents. So it becomes a much more advanced problem. But just for introducing you to AI, Ollie Owl seems to be doing just fine with the few examples and the little processing it has right now. So good question there. But before I kind of talk about kind of the last part of this, which is kind of where to learn more about these topics, I need more questions about just conversational AI. And feel free to branch out a little bit too. Going once, going twice. Alrighty then. So last but not least, what I'll go over is where to go to learn more about AI. Before I talk about that though, is why should you learn more about AI? Is one, just because it's very prevalent nowadays in most software applications. You'll see some application of AI. And also I think now is really a great time to learn about AI because it's a lot more accessible than it used to be. As you see here, even in some block-based coding language, I'm able to apply a little bit of AI just to make something a little bit more interesting. Also, personally, I just think like, playing with AI is fun, right? Like, for me, I'm an educator, so I, spend a lot of time training kids. And it's interesting to see how that works in parallel with when you're trying to train, technology to do something. So it's a really interesting way to interact with technology. And you can, with AI, you're really able to really expand on what you're able to build and the types of experiences you will allow your users to have. So what are good places to start learning about these topics? So if you like taking online courses, deeplearning.ai, has a lot of good material. Here I linked the course AI for Everyone, but they also have courses, specifically for NLP, natural language processing, and other topics. Another place that I like is fast.ai. It's another place that has pretty good course that's pretty accessible, that someone with only introductory knowledge is able to understand. And also Harvard CS50. I don't know how many of you are aware of Harvard CS50. It's a really large introductory computer science class, but it also has extensions. And one of their extensions is AI, and it's pretty good material as well for those of you who like taking courses online. And all of these are free resources, and they're available to you online. If you like building stuff, Kaggle is a online competition platform, but it's more than that, in that Kaggle has a lot of tutorials where you can follow through and just learn how to do certain things with machine learning. And also you're able to see what other folks on Kaggle has built. So it's a very large community. You're able to see what other professionals are building and see their actual code and their reasoning behind it. So it's a pretty good place to learn as well. And Driven Data is kind of similar, and it's another machine learning platform where you're able to apply AI for very specific use cases. And then if you like social media, this isn't an exhaustive list, but some places are good to follow. Towards Data Science, it's more of a data science kind of blog, but it does have quite a bit, a lot of material on AI and machine learning as well. So that's a good place to follow. Cassie Kozyrkov, also posts a lot of good information and blog posts and just info about understanding how AI works and also how data science works for that. And then Andrew Ng made the original MOOC machine learning, someone that I really look up to. But again, and all deeplearning.ai stuff comes from his organization. So, a lot of good material there that you can follow. Someone asked, for a visual learner, where can you find a good tutorial or channel? I actually really like, I think the ones here are really good, especially Cassie Kozyrkov's materials, and really good, interesting explanations how to think about AI, how to think about data science. So I definitely recommend that as well. And come to other places, Deep Learning AI, Fast AI, Harvard CS50, they're all really good material for learning more about this stuff. So, that's kind of all I had for today. So kind of what I had in mind is for this last 20 minutes, just to leave it open for kind of an open discussion around different topics, right? So you can ask more about specific, hey, where can we learn more about AI? You can also ask questions around specific topics within AI that are more advanced, or just anything. And I kind of left this time open for you all to pose questions here. So go ahead and just post questions in chat or the Q&A. Can I talk about my favorite AI project? Oh, that's a good one. So at the moment, I'm in the conversational kind of AI space. And kind of my favorite projects are kind of more so around conversations and those things. So of the ones I worked on, I'm trying to think because I worked on quite a few. Yeah, I need to make sure it's one that I can actually talk about that's not confidential. Trying to think here. So I made an AI that could fill out PDF documents, which, filling out PDF documents is just a pain in the butt in general, but it's able to extract information for what you say and use that to fill out a form in a very flexible manner. So if you imagine like talking to someone on the phone, sometimes you're forced into this very scripted interaction as you're trying to, as the person on the other line trying to fill out information. And I built kind of a, template project where, focusing more flexibly, provide information and, handle that interaction related to form filling. And then outside of AI, though, so another thing, that I'm fairly, passionate about is education, as I mentioned earlier. So, recently I made, a series of lessons in a very short curriculum, for non-technical folks to teach AI. So what I actually did with that project was I took my curriculum, gave it to my friend who actually just finished up high school, was an 18-year-old, and told him to run an AI camp. And he's actually running it and doing well with it. And that's something that's really exciting because what I really like to see is just, expanding access to, this information. And, that's something that I'm really passionate about. Thanks for the question. Any other questions? Any questions related to AI, my career, conversations? Here's a question from our Discord. Does he know of a more accessible guide to the math necessary to get into AI? Very good question. And there's two, this is actually a two-parter. So I'll kind of, talk about kind of my thoughts on just what is the necessary math, and then also how do you learn about it. So kind of before even getting into the math, I think what's important is even before you start learning about math, try to understand AI at a high level, right? What is AI doing conceptually without the math? And trying to understand what's the purpose behind doing things using AI? Because I think one of the reasons why AI has become more accessible in the past few years is that there are more tools coming out that don't require a whole lot of math for folks to use. And I think it's first important to understand how do you apply ML before even getting into the math of it. And once you understand, how ML should be applied, then you start learning about the math, right? Then, the proofs and kind of what's under the hood. And why do I recommend this approach is, at least in the kind of the projects I've been involved in, at least like 90% of your time is spent not necessarily working with the machine learning model itself, but more so with just trying to get the right data and, to train the model. And there's a lot more kind of just data wrangling and data acquisition and data management involved in most projects than the actual AI stuff, which is why I kind of recommend prioritizing those things before you get into the math. Now, let's just say that, you learned all you can without the math. You understand, what's good unbiased data. You understand how, AI projects should be managed. And you want to get into math now. What are some accessible guides? I think, at least based on the things I've seen, I think Andrew Ng, kind of who I, referred to earlier, has, at least to me, he explains the math in a way that's accessible to me. And then there are other folks as well, I think, online if you just search up. Fast AI, I think, has a little bit of math, but they're focused more so on application. But I think, they're also a good place to kind of learn about these topics. And kind of, before going into kind of AI specific math, kind of what are the math skills needed to kind of get started? I think definitely knowing a lot about linear algebra is important, and also knowing a little bit about just how differential equations work. So I think for me it was like Calc 4, but it's not too heavy. So those are things you can do to kind of learn more about ML. Good questions. Next, do you think it's possible to make robots very, very similar to human beings using AI in the future? So that's a really good question here. And I think, when we're talking about AI, we need to take a step back, right? In that right now, kind of as I mentioned before, when folks are talking about AI, most of the time they're specifically referring to machine learning. And as you see here with machine learning, even though it's a really cool tool, it's more so used for very specific purposes, right? Like even in intent classification, it's doing one very specific thing. And there are multiple models working together to enable conversations to work. But right now, it's not really generalized, right? The AI is kind of very specific. And a lot of times when I get questions around AI being similar to human beings, it's real more so around this idea of kind of generalized AI that does everything that human does, right? And I think that there's a few things with that. One is that I don't think there's a whole lot of desire from a business standpoint to make robots too human-like. If you look at most like businesses, humans, even within the businesses are doing very specific tasks, right? And those are the things that kind of the industry is focused on. So I'm not necessarily sure that industry is really focused on building generalized AI. But other thing is, I think another way to think about AI is it's an imitation of what humans do, but the goal isn't necessarily to copy exactly what humans do, because as humans we're imperfect, right? Like even when we looked into kind of training data earlier, as you kind of saw, even learning from the training example, some folks recognize different patterns from other folks, and that might not be something that we really want to replicate with AI. And given that AI isn't human, it's able to do some things that humans can, right? Like learn from a lot more examples and remember stuff. So, kind of going back to this original question, do I think it's possible to make robots very, very similar to human beings? Maybe. But I just don't think necessarily the need or desire is necessarily where it needs to be. But good question. And next, do I think that in this day and age, conversational AI can be useful in social and political contexts? This is a good question. Social and political context. So one thing I've seen recently, I can't actually talk about this. I won't talk about anyone specific, but with Clink right now, just as a business, there are a lot of requests for COVID bots because everyone wants to build conversational AI to distribute information around COVID. Won't name anyone specific, but a lot of requests have come for that. And that's one area where I think this is useful, right? Because it's not easy getting on the phone to talk to someone about it, especially if you're worried about judgment or other things. And also just there isn't a lot of folks available in call center just to always answer questions about COVID. So that's a very specific case where we had a conversational AI solution. We're able to kind of expand the availability of this information around COVID, which I think is very useful. And then going to political context, it gets a little bit more dicey there, just because I think, Joe, I have my own political views, but I think right now in this day and age, it's really hard to define kind of what's useful in political context, just because everyone's trying to, spread their own political views, right? And what one person might say is useful may not be useful to another person. But I do think that going back to kind of what's called, conversations in general, any conversation that you think is very valuable to your life is something that can be, imitated through conversational AI. And any of those applications is something that, I hope people will start using our technology to build. So that's kind of my workaround answer to that question. Thanks for asking. So next question, what exactly makes level 5 autonomous driving a challenging problem? Is it a matter of having enough edge cases in the training data? Ooh, very good question. So there's a few things here. For folks who aren't, super involved in the automotive industry, basically, when we're talking about self-driving cars, there are, 5 very specific levels defined by the industry. Off the top of my head, I don't have the breakdown, but level 5 is basically like a fully autonomous car that doesn't require any kind of human input. So what makes it, a challenging problem? Well, first of all, when we're talking about the AI used to quote unquote train, autonomous driving, it's a little bit different than the machine learning I showed you right here, in that what I've shown you today is something called supervised learning, meaning that you see these training examples, and then based on the patterns you learn from those training examples, you apply them to new cases. With autonomous driving, there's another type of machine learning at play called reinforcement learning. And this idea is with reinforcement learning is that instead of having these training examples, you have some sort of policy or a way to evaluate how well you're doing, like a score. And instead of trying to learn from training data, what you're kind of doing is you're doing these actions, giving yourself a score, and then over time learning what are the patterns that enable you to reach a higher score. So it's a little different approach. So it's not so much gathering as much data as possible. It's really thinking about building really good policies around that. Now, what's the challenging? Well, one thing that I just know because I've been in Michigan is that even from a sensor standpoint, there are a lot of factors that happen when you're driving, right? For example, you may need to recognize your lane lines, and it may be covered by snow. You need some way to recognize that. Or it might be raining really hard, which will affect the quality of the training data. And these are all challenging problems to address that aren't necessarily AI specific, but things that just drive the data that's feeding into the AI. Other things I can just think of is also just from a policy standpoint, right? What should insurance companies do when you do get to level 5 autonomous driving? There will be accidents, right? How do you, once you go into the courts related to car crashes where there are injuries or maybe even fatalities, how do you actually, determine who's at fault given that it's autonomous? And these are all questions that folks are exploring but haven't been fully answered yet. So that's just, part of it. But, kind of just taking a step back, autonomous driving is just a challenging problem in general just because how large it is. And yeah, the consequences when things go wrong are pretty serious. So it's definitely something that's pretty interesting. It's a good question there. Next, have I used any of OpenAI's GPTs? Short answer is no. Right now, because I'm working with conversational AI, and generally conversational AI works with text. And one nice thing about working with text is that you don't use up as much computing power or data as images. Because if you can imagine, even with text as process, it's taking up a lot less data and a lot less storage, and it's a lot less work to get through them. So the kind of the tooling involved for text processing or anything conversation related is not as intensive as something required for like image recognition. So that's kind of something around that. Thanks for your question. Next, how does one recognize what method of AI is better suited to a model aside from the type of data set? Very good question here. So one thing that's, I think, underrated, I mean, not necessarily underrated, but, folks don't, I wish folks spent more time thinking about is this whole idea of model evaluation. So one thing that, for me personally that I get annoyed at is a lot of folks use accuracy to talk about how well a model works. And they'll say things like, hey, this model is 97% accurate. Well, a 97% accurate model, that doesn't tell me much, right? Because if you imagine, let's just say that, you're trying to diagnose a disease and 97% of people don't have the disease. Well, if you just made a quote unquote model that always said that people didn't have the disease, well, you're going to be 97% accurate, right? And it's not really a useful model because what you actually want is you want a model that recognizes people who have the disease. So what this really comes down to is really understanding how do you evaluate the results that your model produces. And, I didn't go too much in depth about that today, but some of the courses and resources I listed here does go more into kind of how model evaluation works. From a conversational AI standpoint, I think one thing that we look at a lot from not necessarily model evaluation, but just from a use case evaluation standpoint is we look at something called containment rate. And what is containment rate? It's just, for someone interacting with something built using Clink, how often do they, give up and just request a human? So if you can imagine, if you have a really high containment rate, what that means is folks are really, they're okay with interacting with your AI application and they're not frustrated to the point where they want to interact with human. If you have a low containment rate, that just means that, hey, your AI isn't good enough and people just would rather talk to a human. So that's one thing that's specific to conversational AI that I've seen. for model evaluation. But then as you're kind of building up your AI, how do you kind of get a feel for what method will work better? This is where having a lot more knowledge of math would help. If you understand kind of how each model works from a mathematical and theoretical standpoint, it would help you with identifying the right model to select. But I'll also say that I still recommend, like, even if you know kind of what approaches work well, still try multiple approaches and still have some sort of evaluation metric, because I think at the end of the day, those metrics should be driving which models you select during your actual project management process. So good question there. Any other questions around AI, conversational AI, career stuff, anything? Going once, going twice. Well, first of all, thank you all for hopping on today to learn more about AI. It's a topic that I'm really passionate about. And then materials from this talk will be posted on GitHub. I haven't posted it yet, but once I post it, I'll make sure to communicate it to folks so that I can reach you all who attend this talk. And also, feel free to reach out to me on LinkedIn. I'm just Album Lee, or even feel free to just email me, and I'm happy to respond to any questions you have afterwards. Because that's kind of what I'm most passionate about, which is just spreading information and around AI topics. So I'm happy to answer any questions you send out to me. And with that, I'll let CodeDay wrap it up from here.
All right, I want to thank everybody for attending this talk. I'm super glad that we could have everybody. So thank you, everyone. Bye.